Hi everybody, I'm Denise and we are going to perform ideal gas experiment together. I select PC version because I use a PC and enter chemistry lab because my experiment is in chemistry lab. I find the ideal gas experiment, access the manuals if I want to in English and Turkish, and start the experiment using the start button. Select English among Turkish and English and find Amy. That gives us some theoretical information.
Hello there, I see a science enthusiast. Welcome to VRLab Academy. I'm Amy, your lab assistant. In this experiment, we will learn ideal gas laws. A gas which obeys kinetic theory and do not have any attraction and repulsion forces between the particles is defined as ideal gas. In reality, there is no such gas in ideal gas behavior. They come closer to ideal gas behavior under high temperature and low pressure. Gas laws are used to foresee the behavior of gases. We will learn Boyle, Charles, and Gay-Lussac laws in this experiment.
And now I have to click on the digital tablet, which turns blue. I find my theory on the ideal gas laws, the materials that I am going to use, and the experimental procedure. We are going to start with Boyle-Mariotte law. I left my tablet using my right click, go around using ASD, W and arrows on my keyboard, and change my point of view using my mouse. In order to start with the first experiment, I have to use my digital tablet, go back, and go to the experiment region and select the appropriate measurement, the appropriate experiment. So I first have to go to a constant temperature of 30 degrees Celsius, and for this I right click, left my table. You can see that the setup is composed of a piston that we use to change the volume of the gas, which is going to be done afterwards. And this is a heating jacket, which enables us to have a constant temperature inside of this piston system. So what we have to do is to come here, use the arrows to go to 30 Celsius. And you can hereby see that we can now start the experiment. As you can see, we have this 30 degrees. We will change the volume and see what happens with pressure for this law. So we select the volume that we want to measure. And in order to save a data, we have to press this button here, so we can see in the tablet that the first point has been saved. Let me see. Yes. So now I change volume, see what happens with pressure, and save my second data. I have to select 5 different data. And observe what happens with increasing volume. You can see that the table is full, and we can save our data and access it using my data section and draw the graph for this law. You can hereby see that with increasing volume, the pressure is decreased, which is what is said by Boyle's law as well. We now go back, select Charles' law, for which we have to have a constant pressure of 2 atm, and we are going to change with play with temperature and see what happens with volume. I right click and left my table. I change my pressure to 2 atm and play with temperature. I have played with temperature and see and record the volume data. I save the data, change the temperature, see the change in volume, and save the data, change the temperature, observe the change in volume, save the data. I will go above 100 degrees, record the volume data, and I suppose that this is my final data point. And record my data. Let's go to the tablet, take the tablet in our hands and see that with increasing temperature the volume has increased. I save my data and draw my graph. You can hereby see that increasing the temperature has increased the volume. Finally, let's go to the third law, Gay-Lussac, and have a 5-liter gas in front of us, which is supposed to be helium because it approaches ideal gas behavior. We will change the temperature and observe the pressure. So we use the arrows, go to 5 liters. If you don't go to 5 liters or 2 atm for pressure, for example, the experiment is not going to start. Let's save this data, first temperature data, and we can now decrease the temperature, save the second data, which actually is written in here in the pressure section as well, decrease further, if you select data in a broader region, it's going to be better because the graph is going to be more good visually, better visually. I think I have one more data point to be taken. Let's take the last point. Let's go to around 50 degrees and record the data. You can see that the pressure change is written in here. We have decreased the temperature and seen that the pressure has also decreased. Let's draw our graph. You can see the proportionality between pressure and temperature, and as well the values written in the table in here. We can refresh our experiment from this button in here, restart the experiment, or exit the experiment using this button in here. Thank you very much.